Now in the 2026 Jan, question number 2. So in the second question, what do they say is, this figure shows a sketch of curve C with the equation of this. So this is our C. This is our C, and this equation is the line that we know, which is y equals 2 to the power negative 0.1x. Okay, now they have given us the corresponding value of x and y for these values. It's given up to 4 decimal places. Okay, so as we can predict, this seems to be going towards integration, which is with the trapezium rule. We'll see. The region R shown in the shaded area is bounded by, say, the x-axis and this is our, okay, this is x equals 4 and x equals 11. Yeah, that's correct. This is x equals 4 and this is x equals 11. Okay, use the trapezium rule. Yeah, they itself said it. Use it with all the values in the y in the table to find an estimate for the area R. Okay, before we find the estimate, we should know there is a concept called number of strips. The number of strips means if you have 3 y values, I'm like, if you have three values, so 3 pairs. If it's 3 pairs, then there will be one strip and there will be another strip. For 3 values, there will be 2 strips. So similarly in here, since we have 1, 2, 3, 4, 5, 6 values, the number of strips is gonna be 6 minus 1, which is 5. So let me note it down. Number of strips equals 6 minus 1, which is 5. Okay, and there's another concept called the height thingy. So how to get the h value? It is the what's the width of each strip? How to take that? How do you take it is, you want to see the width to go more towards an average value. What you would do is, you're gonna get the upper limit of the values minus the lower to divide by number of strips. In this case, what is our upper boundary? Our upper boundary is this value, lower value is this value. So what we would take is, we would take 11 minus 4 divided by 5, which will give us 3, because the 11 minus 5 is 15, so this divided by 3 is 3. Okay, so let's note down the values that we know. We know h as 3. Okay, now let's see, with the trapezium rule, we have to estimate to the R. To go for an estimation, to go for an estimation value, what you would do is, you have to think of all these 6 given points. All these 6 given points, what you would have is, area gonna be, remember this equation, area is gonna be, it's like a pattern. If you take the area would be y naught, and like before the y naught, we have to do h divided by 2, then y naught is the last y variable, plus yn, which is the last one, and 2 times whatever in between. So let me write in a better place. Area of the curve would be h divided by 2, then first y coordinate, the last y coordinate, 2 times all the other y coordinates. Everything in between first and the last. So this is how we're going to do. Okay, now let's go back to our question and see what are the h. We found the h is 3 because we found that h as 3. And what is y naught? In this question, y naught value would be this. What is the yn value is this. So to get the area, what we can do is area would be 3 divided by 2 times it by 1.3195 plus 0.4665 plus 2 times whatever in the middle plus 0.808706 plus everything. So that is our answer. So everything in the middle means all these 4 values we have to add up and you times it by 2. Okay. So whenever we did that, A is going to be 3 divided by 2. You can simply add these two numbers. That would give you 17860 you plus, and this full thing would give you 6.4476. So at the end of the game, you will have 12.35 as the A. So this is your estimated area. So they anyway ask us what is the area, and we have to make sure we give it for 2 decimal places. I know while doing P3, everybody knows the approximation and rounding, so I'm not going to do that. Now let's see the B part. They are asking, state how you would use the trapezium rule to get more accurate estimate for the area of R. To go for the more accurate estimate, what you can do is you can actually, increase the strips, right? I'm like how that means we can use more trapezium. So if we look at this one, so here they have only 2 strips, but if I divide this into multiples, so now it has more strips. So the more and more the trapezium you are making, what you would do is this one is gonna be value is gonna be follow the curve more closely. What happens is they follow the curve more closely. That's the reason that we are asking it to be followed like that. Because if you have just 3 lines, just red color 3 lines, then more than that, if we have some lines in the middle, that would make our curve more and more accurate, more and more close even. Okay, now if we come back to the answer, what we can tell is by using more trapeziums, right? Literally, there's another point, you can increase number of strips. That's what I would recommend here mainly. The other one would be making h means whatever the value we calculated for this one, making the h value smaller. So these are the points that we have to identify. So these steps will move us towards a more accurate reading. It's a bit of a theory question, so let's go back to the C part. Now we know when we differentiate this graph, which is this thing 2 to the power negative 0.1x, what we had was 12.35. Okay, now they're asking the part C, we have to do this one. This looks like somewhat what we have, but not entirely. What we can see is there is a power addition. Power addition means there are two powers. That means imagine if we have 2 to the power, if we have 2 to the power 3 times 2 to the power 5, what you would do is you add these powers, which is 2 to the power 8. Similarly, whenever you have this, you can divide like in the previous case. That's the theory behind this. Okay, so it's 2 to the power 3 minus 0.1x. So we can write as 2 to the power 3 times 2 to the power negative 0.1x, which gives you 8 into 2 to the power 0.1x. Okay. Now to go this there, so what we would do is we're going to take, okay, if the differentiation is coming from negative 4 to positive 11, you have 8 times 2 to the power negative 0.1x. We know whenever there's a constant, whenever there is a constant value, we can take that outside. So what it would give is 8 is coming outside, so that will be negative 4 to positive 11, 2 to the power negative 0.1 dx. Okay, within this range, exactly where is this negative 4 to positive 1 came into play was, it is this range, positive 4 to positive 11 to negative 4. This is our coordinate plane. So we know answer for this inequality sign thing without the multiplication. So what it would give is 8 times, this is gonna be the value that we took, which is 12.35. Then whenever you got that value, so now it's just a matter of multiplication, what you have is 98.8. So this is the area for the new curve approximately. Because this is always an approximation, it might be different in another ways. Yeah, so these are the main questions in the question number 2.